Hey there! Yeah, new episode. And this time it's not a guitar, but we're looking at an old guitar amplifier. So this is an early, maybe like first generation transistor amplifier from Italy. It's called a Falcon 125. And these are, I think, pretty rare. I don't think you see them very often. But in my opinion, they are quite interesting. They have some pretty cool and unique features going on. This one currently is in untested and probably non-working condition. I already took a little sneak peek in there and there are lots of leaking caps and I don't want to plug it in at this point. So I think first things first, we'll open it up, inspect it, and try to slowly bring it back to life step by step. Yeah, let's have a look. We have a pretty conventional layout with two channels going on here, where we start with the second channel, or, I mean, pardon my bad Italian, but like this is...
2 gradi canale.
And for instance here, the inputs will be like...
Entrate brillante. Entrate normale.
Like brilliant and normal, whatever.
Volume, alti, bassi.
So this will be treble and bass, I suppose. Then again, Falcon with the cool little Falcon model. Guitar reverb.
125 2C.
And I suppose this stands for like two-channel version, because I've seen one online called just 125 and this just had one channel, so whatever. All transistor, of course. And I do love the little on-off switch, which says si and no. So, that's great. And if we look at the first channel, it will of course have your
Riverbero.
Like reverb and
tremolo with intensità, velocità.
Like speed and intensity. And the most interesting thing is this control here. This is not just your regular bassi control, but actually
medi bassi
is a fun little thing that I already had on another Falcon amplifier. It will change the mid-range together with the bass. It's a pretty unique EQ, and that alone makes the amp pretty fun. And then you have the two inputs as well. I really love the look with this. Doesn't come across on camera too well. I think there's like a brown Tolex with like brown grill cloth and gold piping, gold details on the handle here. If we just turn it over for a second, there's like the type plate in the back. Tiny little port. And this is like a 2-speaker amplifier, but those are like very small speakers. I expected like a 210 or something, but those are much smaller. They're like 8-inch speakers in there. I will have a look soon. Yeah, right off the bat, that's a little bit unusual. The chassis is pretty standard folded piece of aluminum with a transformer mounted on the outside, but that is like the power amp and they just bolted it on top. And those solder points here will be the power transistors, and they are actually inside the chassis. That's fun. So if I want to work on the backside of this, I will have to unsolder the power transistors. Yeah, anyway. The next remarkable thing is this freaking plywood box here, which houses the reverb spring or the reverb tank. And it doesn't have any screws to open it. It actually is nailed shut. There are like real nails in there. Oh well. So if I want to access that, we'll have to pry it open. That's an interesting choice. Then we'll have a look at the speakers down here. And yeah, they are pretty tiny, like hand for scale. 8 ohms, M200.20.CFX, whatever that means. Other one is the same. I suppose they're original. They all have this lacquer on the threads here. Should be original. Then there's of course the power cable and the original foot switch for tremolo and reverb, which is hardwired in, so there's no plug. You just stuff it in the back of the amp. It's plastic, by the way, plastic enclosure, super lightweight. Let's remove the chassis and have a look under there. I can really tell the chassis took a hit from this angle, so the weight of the transformer definitely put a dent in there, which is something I can try to fix. There's like a bolt stuck in there, but it's moving. Another one in the front. And of course it's like super dusty and dirty. Okay, the big reveal. It's coming up here. And now we are inside. Mains wiring, power supply, big power supply cap. Those will be the rectifier diodes, just two there. Of course, the main power transistors inside the chassis. Lots of ports, very dirty input jacks. Some circuit boards. Funnily enough, like many individual circuit boards, not one continuous, but like 1, 2, 3, 4 circuit boards. And some more very corroded input jacks. And super old transistors here going on. What do we have? We have BC209s. Can hardly read that, but they're all BC209. Some have a colored dot on top, which usually indicates like having been tested or sorted or whatever. And a rat's nest of wiring, of course. Oh, that's going to be fun. There are no markings or designations or solder mask on the PCB, so no idea what the components are or do. And of course, there's no schematic online available. Those amps are so rare, it's hard to even find a picture of another one, let alone any information or schematics. Oh yeah, look at this big power supply cap here. And the way it's just oozing out there. So this is part of the reason why I don't want to power on the amp. I just open it up with this still attached, and I saw this from the side. So yeah, that's a big no-go. If your caps look like this, don't power it up. Make sure to check through first. So what kind of electrolytics do we have here? There will be like the big red ones here and there. Like pretty much on every board there will be some electrolytics. There's a small one hiding down there. And those are usually the most prone to failure components you want to replace in an amp like that. Of course, other components can drift or fail as well. But usually, if you see a crusty old capacitor looking like that, it's a big red flag, and you will definitely make sure to check the other ones and replace if necessary. Like the big one up here on the power supply. It's like a 2000 microfarad job. And I believe it has a date code down there, which is like a 69, 25th week, which would match the date code on the transistors being 6928, 6928. Yeah, that should be like a 69 amp. The big one on top here has, well, it has a 70, so might be 70 as well. Yeah, but in the ballpark, right? So how would I approach this? Since I don't know what's going on, I think, and well, I really don't just want to plug it in and possibly damage anything. I believe I want to test it in sections. So might be a good idea to find out what the individual circuit boards do and try to power them up individually with like a small DC voltage. Feed some test signal in there and see if they work individually after replacing the dodgy looking caps, of course. and then slowly work my way up until I get to the power amplifier. I really don't want to fry those transistors. It's gonna be tough to find replacements. So I will make sure I don't power on the power amp and just start by the low voltage stuff and see if there's some life in there, right? The next step for me is to pull out the boards so I can access the underside of the board and actually draw out the full schematic for everything. Unfortunately, those are not bolted in, but there are these, let's see if I can film it, this little metal tabs bent over like that in all four corners. So that's not super service friendly. That's a thing you can probably bend back and forth 1 or 2 times until they break. So I will try to be very careful. If that fails, I might have to make up some mounting bolts. Disconnecting the speakers as well. These are wired in these funny little terminal strips here. And now I can access just the chassis on its own, which will be much easier to... Yeah, first little success here. I probably went a little bit overboard in tracing the schematic and actually making a little component overlay just so I know which part is which. And then we have the actual schematic at the bottom here. It's pretty simple, straightforward, like 2 gain stages, 2 transistors and a tone stack in between. I mean, I didn't expect much more, but that's what we have here. And furthermore, I disconnected the power lines to the other boards here and just hooked in my lab power supply with 15 volts. I suppose it runs hotter than that, given that the main filter cap is rated for 50 volts and the small one here for 30. I guess the circuit will run at whatever, close to 30 volts, I suppose. I'm feeding in 50 at the moment, plugged my guitar in, and then I disconnected the wire going to the power amp and just run the signal from this little preamp directly to my bench amp over here, being careful not to like overdo it with the signals and everything, so I got it pretty low. And lo and behold, preamp number 2 is alive. We have signal. Look what I found underneath the reverb board. So up here on this pin where the 2 red wires come in, this is obviously the plus V, or like the positive supply voltage. And on the back of that pin, yeah, we have this giant piece of whatever solder sticking out. And so this is the side facing the chassis here. And if I look closely, there's even a little bit of the paint peeled up on the chassis down there. Yeah, this is like some nanometers of lacquer away from shorting out. So I will definitely make sure to clip this off. In case you were wondering how I'm tracing the schematics from this, yeah, it's pretty simple on those through-hole boards that just have like a single-sided load. So I usually start just by doing a little sketch of how the board looks like by roughly drawing out all the components and the way they are arranged. Then I will put a transparency on top like that and draw in the traces connecting each of the points. So I don't really care if this is the actual shape and size and everything, just the rough relation is all that matters. And how am I doing that? Well, there's a simple trick called X-ray vision, also known as a simple flashlight. Just going like that and purely visual without thinking about the schematic, just drawing in the traces and how they connect from component to component. And after that, I will use this drawing to come up and draw like the schematic out. And finally, when that's done, I will give each component like a designator so I can keep track. And finally, I will look for the actual values. That means like the little line codes on the resistors and whatever it says on the condensers and so on and so forth, and put it all in a schematic. So in the end we get something like this, which is pretty much your basic schematic. First quick test of channel 1, the one with the effects now, and unfortunately I'm getting nothing. I'm feeding in a 1K hertz sine wave, and I have my little test amp hooked up to a little capacitor here, which I will use to probe signals. That means the capacitor is blocking any DC. If I crank up the volume a little bit. So here we have the sine wave coming in. You can just about hear that. And now this is the first transistor for the channel. And on the base leg, the one on the bottom there, we have some signal. And where we expect it to come out on the left here, on the collector, nothing. I also checked voltages, and the little transistor has like okay voltages all around it, considering I'm running it at lower voltage than rated. But still, since I got signal on the other channel, this thing might be broken. So right away, the very first gain stage doesn't pass any signal. Let's take a look at this fun little reverb tank here, which is more like a reverb box. Yeah, so let's check the resistance. And we get about 300 ohms on the input and about the same on the output, which is unusual. But I tested it with some signal and I don't get any signal back out, so there might be something mechanically wrong, like the spring unhooked or whatever from vibration. So yeah, we should open it up. Let's get rid of some of the dirt here. Yeah, I think we got it. First side is coming up. Ooh, we got some glass fiber insulation going on and the cutest, tiniest spring reverb ever. Check this out. Tiny 2-spring tank suspended in its own little spring mounting. I must admit, that's better than I expected. I thought there would be like one tiny little wimpy spring in there and maybe some piezo driver or some stuff like that. That looks reasonable, although the mounting is a little bit funny. One of those springs came off. This should be connected to there. Hold on, there's a patent number for anybody interested. Yeah, I'm sort of running in circles here. The tank seems to work after all. I've hooked it up directly to my test amplifier without anything in between. And if I just bump the tank a little bit, you can definitely hear it. And on this probe I have a test signal. And I'm just feeding in test signal directly without any preamp. And there's definitely a short reverb signal going on there. And trust me, the reverb on the amp is on 0. I tested it with the circuit before, and I could get signal in, but it didn't get anything back out. But when I fed signal into the return, it also worked. So maybe it's, like I said, a problem of not enough voltage, so I should put it aside and tackle the power supply first. I will start by replacing this main filter cap over here and see what sort of voltages we get within the system. Notice this entire amplifier doesn't have a single fuse in there. There's no primary mains fuse, no speaker fuse, no secondary fuse. And this thing on the front here, which looked like a little fuse holder, is actually just like a mains input voltage selector. So you can go from 220 to 120 and whatever, like these 4 windings on the primary here. This is actually kind of like a trap. It's really hard to read in the front. If you set it wrong, you can blow up your transformer. I'm thinking about removing the wires and putting them to the side and just having it hardwired on one setting so you can't accidentally mess it up. And I will definitely go in and maybe in the back install a fuse holder for the primary. For now, before we get to soldering, I will just clip out one leg of the filter cap here, so it's out of circuit. Here's a name brand like Nichicon cap of the same value. Unfortunately, it's not like the axial type with 2 legs, but like radial with legs on the bottom. Yeah, so what? It's not a valuable collector's amp where these sorts of details matter, so I will just hook this one in temporarily with 2 alligator clips and measure voltages, and then we'll decide on the way forward if this is adequate or not. I'm using the big variac here to slowly bring it up in mains voltage. Right now we're just feeding in like 80 volts or something, not drawing any significant current, which is good. On here I have the old cap removed and out of circuit. The new cap is clipped in. And there is nothing connected, like no load on the power supply. It's just running empty right now. And we're measuring like 11 volts DC. And now I will just slowly bring it up and see what we get and hope nothing explodes. So let's go to 100 volts and we should see rising DC, which we do, 15 volts. Step to 150. We're on 21.5 already. Let's remember the cap is rated for 50 volts. All the way to 220. And we get 31 volts DC out of the power supply. Here's a little safety thing. I just switched off the supply here, and the cap is of course steadily holding on to its 31 volts in like 2000 microfarads because it doesn't have any load or any bleed resistor to get rid of the charge. It's obviously not as much energy in some tube amp filter caps, but still I should probably discharge it before handling it any further. The Nichicon cap is in there. I just shortened the little bracket so I can reuse it and put some longer leads on there that will connect here and there. This is the other like ground wire going on. And for this fun little thing in front here to select the voltage, I've decided to leave it in place just for original looks. But I've removed the center was holding the live wire from the input cable. Like this is the mains cable. The brown one here is the live wire. I removed that, as well as the brown transformer primary wire. And it turned out the little pilot light got its power there as well. So this is the red one. I will all put them towards the back here and install like a little fuse holder next to the power cord here. fuse holder is in. Now we can connect some wires to it. That's the pilot light. That. But we're getting there. Also a lot of solder. Wow. You can already hear it humming in the background, which is good news. As you can see, I set it all up, including the reverb tank here. We have replaced capacitors on every board, like up there, and those two and there. And it's picking up interference from my little camera here, which is kind of cool. But the good thing is we have a completely working preamp now. I think this fixed the issue. It was probably all related to wrong voltages. So just having voltage on a transistor doesn't necessarily mean it's working correctly. When the filter caps are old and leaking, there could be weird, funky voltages. And now, yeah, quick demo. It's channel 1, treble. The funny mid-range control. Now check this out, reverb. Nice short decay time there, I like that. Tremolo. Super choppy. Nice, but that means we have a completely working preamp.